Myself, Mrs. M. Vijay Sabarishwari, working as an assistant professor in ECE department in Sri Shanmuga College of Engineering and Technology. Today, we are going to see the topic graph theory. So graph theory, it is very useful when we are analyzing the electrical circuits. So the electrical circuits is converted into graphical representation for the analysis of complex electric circuits. So what is graph and what is graph theory means? When all the elements in a network are replaces by lines with circles or dots at both the ends. This configuration is called as the graph. So the electrical circuit, even though it consists of so many number of passive components, all the components are replaced by a simple branches. So branch is nothing but the straight line connecting the two dots. So that is called as branch. So the connecting dots are called as a node point. So here the graph only consisting of branches and nodes. Then network topology means this graphical representation of the network topology is called as a graph theory. So here, so this is the electrical circuit. This electrical circuit is converted into graph. How means all the passive components and active components are simply removed, and all the branch is connected as a straight lines. So the node points, when two or more branches are meeting at a point, that point is called as node. So here there are three branches are meeting. So this is the first nodal point, this is the second nodal point, and this is the third nodal point, and finally this is the fourth nodal point, which is connecting all the components to the ground. So this one is taken as a reference node. So we are having a four nodes. The same is represented in here in graph 1, 2, 3 and 4. Then the branch is here, it is connected as a straight line or curved line. We can use both the types when we are connecting the nodes. So the connecting of branches between the nodes may be a straight line or a curved line. So 1 to 3 it is connected here, and 1 to 4, 2 to 4 and 3 to 4. It is all connected here. So in this graph there are 4 node points and number of branches are 1, 2, 3, 4, 5 and 6. So there are 6 branches in this network topology. So 4 node points and 6 branches. So some basic terminologies are used in network topology, that are path. First one is path. Path is nothing but a sequence of branches traversed is in going from one node to another is called a path. Then node. A node is a point, is defined as end point, a line segment, and exists at the junction between two branches or at the end of an isolated branch. Degree of a node, it is the number of branches incident to it the node. So that is called degree. So look at this diagram. In this diagram, the path is from R1, Ri and this node. So the path can be defined with the direction also. So if it is given with the direction, it is called as a directed graph. If it is not given with the direction, means it is called as undirected graph. So node means the meeting of two or more branches is called, that point is called as a node. So here this dot is considered as node. Then degree of a node, how many number of branches incident to that node is called the degree of node. Tree, it is an interconnected open set of branches which include all the nodes of the given graph. In a tree of the graph there cannot be any closed loop. So in the network topology, all the open branches with the all the nodes is called a tree. So without leaving any nodes, but we can leave the some branches to make the topology in a open set. Then tree branch, it is the branch of a tree. It is also named as a twig. So the branches of a tree is called as, also called as twig. Then tree link or cord, it is the branch of the graph that does not belong to the particular tree. That means if you are making that branch connected to the tree, then it will become a closed loop. Then that link is called as a cord. That means the tree is a consists of open set of branches. Along that branches, when we are adding some more branches, but that branch made that topology as a closed loop, means that is called as cord. Loop, this is the closed contour selected in a graph is called a loop. Then cut set, it is the set of elements or branches of your graph that separated two parts of your network. If any branch of the cut set is not removed, the network remains connected. Then it is called as a cut set. So we can derive this property by dividing into two parts of the network. Then code tree. So this is the original diagram. So in this diagram we can have a tree structures. So tree structure means we should include all the nodes. So the total number of nodes are 1, 2, 3, 4 and 5. So the number of nodes here is 5. So we should include all the 5 nodes. This is one type of tree. Then we can add branches to that node, but that branches should not make the circuit as a closed loop. So this one is closed loop, so this cannot be considered as a tree. So this is only as a tree. So without, after removing the tree, the structure is called as a code tree. So in this, look at this diagram. In this, so the tree is in blue line, the code trees are in red lines. Then one more diagram, 1 to 4, 4 to 5, 5 to 2, 2 to 3. This also can be considered as a tree because all the nodes are covered in this way, but it does not have any closed loop. So this can be 1, 4, 4 to 5, 5 to 2, 2 to 3. This can be considered as tree. So apart the tree branches, remaining branches are called as code trees. The same way, 4 to 1, 1 to 2, 2 to 5, then 5 to 3. So this can be also considered as tree. So the remaining branches we are having called as a code tree. Okay, consider this example. So we are going to convert this electrical network into graph. So the same way, all the components are removed and all the branches are connected to the nodes, the respective nodes. So here the total number of nodes are 1, 2, 3 and 4. If it is connected to the same node, then it is called as a self loop. So the network is converted into graph and the respective branches are mentioned as A, B, C, D, E, F, G and H. So from this graph, the orientation graph means the graph having the branches mentioned with the directions. Then it is called as a oriented graph. So in that, the tree structure means the tree should have all the nodes, but all should be a open branches. All should be a open branches. Then code tree means other than the tree structure, what are the leftover branches is called as code tree. So this is the non-plane. Next one is tie set. So this is similar to the cut set matrix. So it is a unique set of with respect to given tree at a connected graph containing a on chord and all of the free branches containing in the free path formed between the two vertices of the graph. So network variables means a network consists of passive elements as well as sources of energy. In order to find out the response of the network through the current and voltage across each branch of the network or also B can be obtained by using same variables voltage V and current I. Directed graph. A graph is said to be directed or oriented when all the nodes and branches are numbered or direction assigned. Subgraph. A graph said to be subgraph if every node of the node and every branch is also a branches of G. Then it is called a subgraph. Connected graph means when at least one path along branches between every pair of graph exist. It is called as connected graph. Incidence matrix. Any orientation graph can be described completely by using some set of matrix form. So here we specify the orientation of each branch in the graph and the nodes at which this branch is incident. So this matrix is called as incident matrix. When one row is completely deleted from the matrix, the remaining matrix is called as a reduced incidence matrix. So whenever the branch is incident on the node, that should be considered as +1. When the branch is leaving from the node, that branch value is considered as -1. When the branch that not related to that node means it is generally taken as 0. So by using this +1, -1 and 0, we can form the incident matrix of that network topology. Isomorphism, it is the property between the two graphs when that both have got the same incident matrix. If both the network topologies are having the same incidence matrix, then it is called as isomorphism. Consider this example. In rank, for this electrical circuit, rank means n minus 1, whereas n means the number of nodes. So here the number of node is 5. So the 5 minus 1 is called equal to 4. That is called as rank. So the number of branches is also n minus 1. So 5 minus 1 means 4 branches. So path connected to all the node, disconnected to the loop. Maximum number of branches is equal to number of nodes. Links means the path between any pair of vertices is also called as links. So at least 2 branches in this circuit. Here so 1, 2, 5, it is one kind of closed loop. 4, 5, 6 is one kind of closed loop. Then 2, 3, 4, it's one kind of closed loop. So fundamental circuit loops. So loop is nothing but a closed contour. Then the tree structure, when all the nodes are connected, is one kind of tree. This can also consider as tree. This type can also consider the tree. So the definition for tree is the tree should have all the nodes but does not have the closed set of branches.